Hey, hope you're all doing well. This is a follow-up video to Handbox's excellent work on converting your Nagra to a Melotron. This is a speed control circuit that I've come up with that has some safety features built in. Here's my Nagra going for it right here. So yeah, we'll take a look at what's happening with the Mordax data. And then I'm going to go ahead and show you a couple of different ways to do this. There's the speed control on the breadboard there, and I've got it running from the pressure points, of course. And then let's go all the way. All right, let's get into some details here. So indeed, the voltage range should be kept between negative 3.3 volts and negative 6.3 volts. Through some Nagra abuse and experimentation, and mostly abuse, found that, yeah, you go any higher than negative 6.3 volts and it wants to stop. As you approach negative 10 volts, it wants to stop. Any lower or closer to ground than negative 3.3 volts, it wants to fast forward, just starts running away. One thing to note is that if you're monitoring your output, or you're grounded to your modular itself, don't put another ground on the ACC. It creates a ground loop and won't respond to any signals coming in. And then there's an issue I'm having with my ACC port. They're very loose. The darn thing's so old. So the idea is to build up the outside diameter of these pins with some solder, so it just gives a little more solid connection. And then I'll show you there is another option for wiring to the inside of this guy, although there's really not a lot of room in there. It's a jungle in that Nagra, but we can get into that part later. So let me show you some details here. All right, so here's the package for the Touch L 6 pin connector. And this is available DigiKey, Mauser, or there's a really cool guy on eBay called Fletch. Thanks a lot, Fletch. Great hookup. That guy does some really cool accessories for the Nagra. If you want just a standard manual control, here's a schematic of that. And this runs completely off the ACC port itself. It's taking the negative 10 volts from pin 6, your ground from pin 2, and there's your speed correction, right? Do not leave out this 1K resistor, right? So you want to, it keeps from having too much current drawn through this, especially if you happen to ground one of these trim pots here. So you've got a trim pot here, set its output to negative 3.3, trim pot here, set its output to negative 6.3, right? And then as you vary your speed control, you're going from negative 3.3 to negative 6.3. Okay, here is the ACC pinout. All these documents are available on the Nagra website. Excellent website, great resources. You'll notice also here is the external power supply port. It also has the speed correction signal, which in fact on the inside of the Nagra is copied all the way across. So the other way to get to that pin, if you don't want to go through the ACC, is right here on pin 10. And that pin is available on this long card that's in the back. And then this shrouded connector, it's like a light green color. There's pin 10 right there. So you can get to it another way, through the back or through the inside of the darn thing, but it's a jungle in there. All right, so let's see. I'll show you the, so there's the trim pot back there. Let's get into the actual circuit itself. All right, so we've shown you the manual way to do it. Here's the circuit that's on the breadboard itself. A little convoluted. Took me a little while to nail this. So let's get in here. So we got 100K input impedance, 1K output impedance, right? So we're matching our Eurorack standards. First up, op amp 1 is a half-wave rectifier. Okay, and you notice that we're monitoring off the negative pin, not off the output. That's very crucial. Okay, next up you've got an inverter, just straight up inverts the signal. Next section is scaling that, all right? So your negative feedback resistor for 0 to 5 volt input, 68K. For 0 to 10 volt input is 30K. Sorry, it's all smudged there. There's our protection. Our Zener diode limits the output of this to a 3 volt swing approximately, okay? Next up is our little math area here. And this trim pot, you want to set it to a 3 volt output. And of course, you know, unhook this from the op amp, set it for 3 volts, and then plug it in. You know, if you try and monitor your incoming voltage right here, it's going to be 0, right? Because your positive pin is 0. Okay. And then finally is a slew limiter. I chose to put this in just to keep the output from slamming the Nagra back and forth. I found that it was not super happy doing really fast transitions like that. If you choose to take this out, do not remove the 1K resistor, right? This is limiting our current that's being drawn right into the Nagra itself. Okay, so it has all the safety features built in, because what you don't want to do is exceed that voltage. So right here is the channel 1 is the output from the pressure points. You can see it's 0 volts, and the output from our speed controller is negative 3.3 volts, right? So that gives us the lowest range at 0. And then if we go straight up to 5 volts, there's my excellent camera work here. Okay, and you can see that our input coming in from pressure points is way higher than 5 volts, right? But our output is limited to negative 6.44. So this safety feature keeps you from exceeding those two values. So no matter what you slam into it, that Zener diode is keeping us nice and protected. All right. Thanks, Zener diode. You rock. All right, and there's that Zener right there. You can see the trim pot in the back. Okay, and that's that, straight up. So I'm gonna go ahead and do a printed circuit board, and I'd like to do Euro rack module as well. If you guys give me the chance to put out my very first Euro rack module, probably gonna offer that on eBay. Here's a little input-output module I did for the Nagra itself, just to bring my signals in, get my signals out to the wonderful Nagra 4.2. All right, I think that about sums it up. Thanks for watching. Take care.